Hi, welcome to Inference for Linear Regression. I'm Jo Hardin. I'm a professor of math and statistics at Pomona College, and I'll be your instructor for this course. I'm assuming that you already worked through the first few courses in the Intro Stats series. In this course, you will be building on your previous work to now make inferential, instead of descriptive, claims based on linear models. In particular, we will use the least squares regression line to test whether or not there is a relationship between two continuous variables. And we will also estimate confidence intervals, which quantify the slope of the linear regression line. We will be working primarily with two continuous variables. Consider the scatter plot here. Fat and calories are plotted for a handful of items on the Starbucks menu. As you did in previous courses, the least squares regression line is fit to the sample of observations. It seems like fat and calories have a reasonably strong positive linear association. A subset of size 20 items shows a similar positive trend between fat and calories, despite having fewer observations on the plot. Indeed, a second sample of size 20 also shows a positive linear trend. When the two samples are plotted on the same figure, we see that the least squares regression lines are not identical. That is, there is variability in the regression line from sample to sample. The concept of sampling variability is something you've seen before, but in this chapter, you will focus on the variability of the line instead of the variability of a simple statistic. Indeed, when we take repeated samples of size 20, here we took 50 different samples. Every single line is different. Notice that the rep sample n command let us take many samples of size 20, and ggplot fit the linear model separately for each of those samples. We can characterize the sampling distribution of the slopes by making a density plot, just a smoothed histogram, showing the variability associated with the different slopes. The R code uses the tidy function in the broom package to pull out the slope coefficient for each of the separate models. Using ggplot, we can plot the different slope estimates. We see that the slopes vary from about 8 to about 17. In no sample did the slope come anywhere close to 0. That is, there is a lot of evidence that the relationship between fat and calories is positive. The same analysis can be done with different variables. Here, consider fat and carbohydrates. Again, for each of the 50 samples of size 20, a different regression line and different slope is calculated. Unlike the relationship between fat and calories, however, some of the sample slopes describing fat and carbohydrates were close to 0, or even negative. Although the relationship is possibly positive, we are unable to make conclusions about fat and carbohydrates due to the large amount of sampling variability. Thanks for following along with this video. Now it's your turn to practice. First, you'll review how to run the linear model using the broom package, and then you'll investigate how the lines change from sample